in the same vein, I want to talk about a new piece of research from the SMART Alliance, which is a partnership between Singapore and MIT. And what they've created is smart plants by embedding sensors in plants so that they can detect pollution. I think that's pretty awesome. And essentially what they've done is by putting these little tiny nanosensors inside plants, they can find out when pollutants are making their way into the groundwater and into the soil and then up into the crops. The pollutant that they're targeting in this research is arsenic.
Okay.
And arsenic is really dangerous to human health, also dangerous to the environment, and it's pretty widespread actually. And the way it gets into our groundwater is from mining. So I think it's pretty important, and I'm glad that they chose a, dangerous and widespread pollutant for their first hack at this research. The way it works is they essentially put a needle inside a plant and inject it with these little nanobots, let's say nanosensors, that can detect arsenic. And they don't cause any damage to the plant, which I think is great. And it's actually much, much better than the current way that we detect arsenic, which is super cost intensive.
Gotcha. So in what ways is it better? Is it more accurate?
It seems to be better all around. Accuracy is just one of the benefits. So the way that they detect arsenic right now, it requires a lot of work and a lot of time. And what they do is they go take samples of soil, they'll take samples of the leaves, they'll take samples of water. So they look at those three things. And then they take it all back and put it in a machine called a mass spectrometer, which is really, really expensive. And it can only detect about 10 parts per billion of arsenic in these places, which is great. That's actually the detection limit that is required by environmental agencies. But the sensors made by the Smart Alliance team is actually 5 times more sensitive, so they can detect arsenic at 0.2 parts per billion, which I think is really, really incredible.
So with this kind of detection, how do you know if the plant has sensed that there is a presence of arsenic?
So the way that it indicates whether there's arsenic or not is it actually, I said they inject these little nanosensors into the leaves of the plant. They actually inject it along the vascular system, which is basically the veins that carry water and nutrients throughout the plant.
Gotcha.
So if there's any arsenic in the soil or in the water that is being sucked up through the roots of the plant, the nanosensors that are sitting along the vascular system will start to grow as arsenic is brought up through the roots and into the plant. And it's by this fluorescent and glowing that they're able to detect it. And really, the only way that they keep track of these, they don't need batteries, they don't need fancy radio systems or wiring to all the plants. They actually have a relatively inexpensive Raspberry Pi with a camera on it. So just think about a small computer with a camera, just like your smartphone, that just looks and watches these plants. And if one of the plants starts to glow, and fluoresce, then they know that arsenic is present.
So they can do this in real time. They can sense the levels of arsenic within the soil in real time.
Well, that's one of the other main benefits as opposed to the current way of detecting arsenic, is it's so expensive and it takes so much time that they only are able to do it a few times every year. But with this new method, it costs a lot less, and they can actually do constant monitoring 24/7 essentially to make sure that there's no arsenic. And that actually has great downstream implications for farmers, let's say. They can tell the day that arsenic contaminates their crops and kind of triage and make sure which ones they need to throw away and then keep the rest. The way that it's done right now, every few months, you could find out too late and have to throw away a substantial amount of your crops.
Got it. Wow, that makes sense. This is a really interesting approach.
Yeah, it's really, really incredible.
And you said it's MIT that's doing this?
It's MIT that's doing it in partnership with a university in Singapore as well.
Gotcha. Wow, that's awesome. Shout out to the folks doing some real great work, making sure we're safe, our soil is safe, and the farmers are protected from wasting tons and tons of their crop.
Yeah.